name is Vijay, and I wear a couple of different hats here at Purdue. The one that she said was as Vice President for the University for Global Programs and Partnerships, but what I've really been up to for the past 3 years or 3.5 years is put together our educational programs in semiconductors and have benefited from. And this course is just one out of a series of experiences, educational experiences, and other coursework, other opportunities for you to get involved in the world of semiconductors that we have at Purdue. And so what I was going to do for the next 15-20 minutes was do two things. Well, actually make that three. One is to give you a slightly broader view of the landscape of semiconductor activities and things that are happening at Purdue, so that you have kind of a global picture and global context for both yourselves, as well as as you have other friends and other people both at Purdue and outside Purdue kind of ask you, hey, Purdue seems to be doing a whole lot in this semiconductors thing. What's that all about, right? So you will be able to help us and be our ambassadors in answering that question well for them. But then also, equally important, which is part two, for you to have a roadmap of what are some things that you can now do now that you've done this course, right? Either the rest of, either the summer followed by your sophomore year, your junior year, your senior year, and then for those of you who are considering graduate school, what are those various on-ramps and those sliding opportunities that you can keep getting involved in, so that you go deeper and deeper into this, into this ecosystem as much as you can. And third, and perhaps most important, is to see as we wrap up this course, and you've heard from a number of industry stakeholders and partners, to see if you have any questions that would help tie in everything that you've heard over the semester, right? Whether it was from the foundry folks or whether it was from the fabulous design houses like Apple and NVIDIA and AMD and stuff. If there's something which is not making sense, or if there's something that will help you connect the dots better, happy to answer any questions. So I've been in the semiconductor industry for about 25 years. I do chip design. I do system design, embedded systems design, which takes chips and puts them into larger, interesting systems that then go into a whole bunch of different products. Some of them are computers, but way more interestingly for me are all those everyday objects around us into which we embed computing intelligence, right? But don't normally think of as computers by themselves, right? So everything from your toothbrush to your credit card to your refrigerator to your microwave to your car to airplanes to lots and lots of other things that you use every single day has a ton of computing in them. Right? And so how do you design those systems? What are those implications, including things like biomedical implants that go into your body, things like pacemakers, right? How do you go about designing the electronics, the chips, for applications like that, where if you put something into somebody's body, you want to make sure, and this thing is running off of a battery, so this is not like a cell phone where you can recharge this every day, right? You want that battery to last 7 to 10 years, right? Otherwise, guess what? You're going to be cutting into that patient to replace a battery, and you really don't want to do that, right? How do you make sure these systems and chips are secure? So that if I'm a bad guy, right, I don't shock you to death, quite literally, right? And that is not science fiction. That is a very real threat. There's been a whole bunch of demonstrated attacks like this, where people have been able to access and gain control of biomedical implants in somebody else's bodies, and that is a huge issue, of course, right? So lots and lots of interesting challenges that are surrounding semiconductors, surrounding chips, surrounding chip-based systems, right? That profoundly impact everything that we do as in science, technology, and engineering. So hopefully you'll get to hear sort of good amount of all of that as well. So when we talk about this big initiative of semiconductors at Purdue, there's really 4 different pillars that we on campus like to think of it as. One, of course, is building the leaders of tomorrow for the semiconductor industry, right? Which is what all of this is about, right? In terms of the creating experiences for you. This is about workforce development. This is about classes. This is about hands-on experiences. This is about ensuring that you have the right connections to industry. All of that stuff, right? We do that. We have a couple of different programs at Purdue that do that. One called SCALE, which is focused on the defense microelectronics sector. Right? This is really to do with anything to do with U.S. national security interests, anything to do with the Department of Defense, because those applications and those companies have a very different set of requirements. Right? Things need to be super mission critical. Things need to operate in a manner that where things will work in extreme environments. If you're mounting some electronics on, I don't know, missiles and warheads and stuff, right? Those are really harsh environments, and your electronics need to be operating reliably despite those harsh environments. You can't say, oh, guess what? My a defensive missile that I launched to intercept something, maybe something that an adversary has launched at you, didn't really succeed. And as a result, I wasn't able to intercept, and that resulted in mass casualties. It's not a good enough reason to say, guess what? That there was a chip that was on my missile which failed, or which was not calibrated well enough, or there was some error, or it was not tested properly. Those are not good reasons, right? There are some mission critical applications where things absolutely need to work. So those defense applications have a different set of requirements. That's what SCALE is mostly focused about. The Semiconductor Degrees program, which is really what this course is a part of, is sort of an even more ambitious effort that we launched this was May 2022, so about 2 years ago at this point, almost 2 years ago, focused on the commercial sector, which is where the vast majority of you, if you pursue the careers in the semiconductor industry, will end up. And designing the variety of semiconductor technologies, whether it is manufacturing, whether it is design, whether it is the equipment makers, whether it is the foundries, and so on and so forth. And we've put together a rich cascade of programs, this being the first step, right, as part of that. The other three pillars are also sort of super important, right? Maybe you don't see a lot of that stuff on a day-to-day basis just yet, but there's a lot going on even in there. Research and innovation, because as a university, in particular, as a research university as Purdue, right, in addition to our educational, academic mission of educating the next generation of workforce leaders, right, innovation is front and central to everything that we do, right? And so there's a number of research partnerships, innovation partnerships that Purdue has launched with lots of other partners, both domestic as well as international, as well as this CHIPS Act thing that many of you would have heard about. I'm guessing some of the speakers would have mentioned that this semester, which is a revitalization of the semiconductor industry and ecosystem in this country, right? The US government is investing a lot of resources for a variety of reasons, some strategic, some for others as well, at rebooting not only and safeguarding supply chains, but also really sort of revitalizing the innovation ecosystem in this country, because the US has been traditionally the global leader in terms of semiconductor innovation, but increasingly we're finding that there's a lot of others that are catching up. And of course, right, the government is interested in making sure that the country stays ahead of everybody else in terms of innovation and new things that come out, which really impact the world. And then there's two other pieces which are even further out, from your radar as students. One is economic development, which is the fact that, although we are a university, we want to make sure that as a land grant university, we're contributing to the mission of the state. And that pillar really has to do with making sure that we attract a strong ecosystem of industry and companies, right here in what is being referred to as the Silicon Heartland, right? So that not all the jobs are out west, but we really take advantage of the fact that there's an abundance of talent here in the Midwest, an abundance of resources and stuff like that, and make sure that companies come in here. You're seeing some success of this, right? I'm sure many of you would have followed the news about SK Hynix, announcing plans at least to open up a big multi-billion-dollar packaging center. So that took a lot of work, but we're all super excited by the possibility of that happening. Although you see SK Hynix there, which is one company, but the hidden layer behind that is a whole bunch of suppliers for SK Hynix that produce their components, that produce the raw materials that go into their factories, right? That produce the various gases and the other compounds that are required to run their assembly lines. So there's an entire ecosystem behind that that will come, right, once an anchor like SK Hynix comes here, right? So there's lots of activity happening on that front. And then finally, Purdue is increasingly being looked at as both a national as well as an international leader in the chip space, right? So we have partnerships with other universities, other industry players, other countries whose governments are now saying, hey, you guys really know a thing or two about semiconductors and bootstrapping semiconductor ecosystem and making sure that you train a lot of workforce in the space. And they want to partner with us, whether it is in terms of creating opportunities for Purdue students to go out and have rich experiences in other parts of the world, or the other way around, right, which is sending even more students to Purdue to come take advantage of all the wonderful things that we do and teach here. So that's sort of the big landscape, right? The Semiconductor Degrees program itself, like I said, is sort of a comprehensive across the university initiative for semiconductor workforce development that we launched in May 2022. And it wasn't really done alone, but this was done really very tightly in partnership with industry, because all of the students that we train, right, clearly, right, you're not going to be here forever, hopefully not going to be here forever, right? You want to get out into the real world, and you've got to go end up in, for the vast majority of you, sort of in a company, right? And certainly if it's the semiconductor field that you're pursuing, in a semiconductor company. And we want to make sure, to some extent then, that these companies are the customers, right, for us, right? Because if we sort of are the ones training all of you, right, and that's where you end up, we want to make sure that by the time you graduate, you will be in super high demand, and all of these companies will be coming after you guys instead of people from our neighboring state of Illinois or Michigan or whatever, right? So we've been very intentional about this. We have a lot of industry engagement and input that has gone into the design of this program, including this course, and that is reflected in just the sheer variety of speakers that you've seen in this course, right? And there's nowhere else in the country where so you have such a wide variety of industry participants and industry speakers coming in and speaking to students. I'll skip like a couple of slides. But essentially what this course is it's really one layer, right, kind of as seen here, right, around your educational experience as you progress from a freshman all the way through to graduation. It's perhaps the first layer, right, for many of you, your first introduction to the world of semiconductors. But then as you go along, if you so choose to go along this journey, there's like a number of other layers that you will get to see as you proceed along, and so that by the time you graduate at the end, right, you would have had a rich variety of experiences, but also be able to pick up formal credentials. I know many of you in this room have already enrolled in the college-wide semiconductor certificate that we have. But also, in addition to that, as many of you transition into your majors, whether it is ECE or mechanical engineering or material science or IE or chemical engineering and what have you, there's other forms of credentials, things like concentrations that are being launched within your majors or future majors, where in addition to taking advantage of the concentration, you will also be able to earn a concentration within your major focused on semiconductors, right? So it's a fantastic way of making sure that, look, you have a college-wide certificate, but you also have something that shows that even your plan of study that you construct within your major is kind of tailored towards semiconductors. And as you speak to prospective employers, that will really show to them that, look, you are somebody, you've made the plunge entirely and made sure that everything that you've learned is really focused in a nice coordinated way, right? So I'll talk a little bit about those experiences, some of those opportunities for you as well. This is that leadership board that I spoke about when I said we built this program in tight consultation with industry. And you'll see that many of the companies that that you got to hear from are actually represented here, right? But there's many more here than the 14 speakers that we could bring in in a semester. So the reason I throw this up is almost all of these companies have made a commitment to come visit campus at least once a year, talk to all of you, talk to our students, recruit them for internships, recruit them for those co-op experiences, recruit them for those full-time new college graduate positions that they have as you get closer to graduation, right? So the point of the slide is simply that there will be a rich variety of opportunities for you as these companies come to campus throughout the year, right? So as you exit this course and enter the summer and then fall, right? Watch out for these companies coming into campus, not just during IR, but really throughout the year, right? And one of the things that we'll be doing is to run a fall version of this course again, right? Because the demand for it is just so high. And we'll hopefully bring a different set of speakers in the fall, and along with each of those speakers coming in and addressing the course, we'll hopefully have almost a day on campus where these companies will be able to, they'll have a table and a booth somewhere where you can wander in and talk to them about opportunities that are coming up in those companies, right, which align with your specific interests. So keep your eyes and ears out, for that. Many of you did participate in some of our awareness events back in the fall, and that will continue, right? Again, as part of our effort at bringing more companies onto campus, but also raising awareness among students about semiconductor careers and about the field of semiconductors in general. So, some of you may have participated in our fall 2023 IR and our semiconductor night and semiconductor event, right, where we had a number of companies, semiconductor companies, come to campus, right, 42, substantial jump up from previous years, and lots of students, right? And so these certainly will continue. So there'll be lots of invited speakers. We are already planning an event in the fall, which will be our second version of the Purdue Silicon Summit. So lots of activities centered around a week, where you'll be hearing so much about semiconductors, and you'll say, yeah, I know what all of that is about. You've done this course, right, which is great, and what this course did is really expose you to what I call the semiconductor value chain, right? And this is just a different grouping of that same slide that you saw on Sophie's foils, where that shows the various pieces, right, that form the semiconductor industry and semiconductor ecosystem. And I like to, one of my favorite ways of viewing the semiconductor industry is sort of like a puzzle, right, where each of these segments forms a piece of that puzzle, right, and they somehow all fit together in strange, complex, but also very beautiful ways at making sure that we're able to do what we do so well, which is power all of the demands for and the need for computing and chips that are in so many different applications, right? And this value chain is broad and deep and expansive. It is global, it is complex, and what that really means is, regardless of what major you choose to pick, there's a place for you in it, right? So you could decide to be, that you like chemical engineering, you like chemistry, right? There's lots of opportunities for you in the semiconductor industry. You could decide that, look, I want to write software, right? And there is plenty of opportunities for you in the semiconductor industry. In fact, hardly any chip is designed by hand these days, right? As you've heard, they're so complex, and you had EDA companies like Synopsys come and speak to you, and I know Harish was here to talk to you. So a lot of chip design these days is basically writing software, right? So you just program in a programming language that looks a little different than what you perhaps were used to programming for your regular software, software applications in. But that's what it is, right? And then you go through, you use a whole bunch of sophisticated computer programs, right? These are design tools, which will take that code that you write and somehow translate that into a design, right? That you then can send off for fab and so on and so forth, right? So there's a place for you if that's the kind of stuff that you want to do. If you want to be if you want to be a mechanical engineer, you want to be even an aeronautical engineer, and believe it or not, there's plenty of opportunities for you in the semiconductor industry, because guess what? With some of these equipment that the foundries use, the operating environments inside these equipment, they're like super harsh, right? And so if you're trained in an aero program that teaches you about plasma and sort of environments that exist near jet engines and that kind of environment, right? And how do you model that? How do you make sure that you create materials that can survive those harsh environments and stuff? All of that stuff is actually applicable to what happens inside some of the semiconductor manufacturing equipment, right? So you're in very harsh environments. There's harsh chemicals. There's harsh temperatures, high temperatures. There's all kinds of crazy stuff which is going on, right? So even if you're an aeronautical engineer, right, you might not think that there are opportunities in the semiconductor space, but there's plenty, right? So for every single one of you, right, regardless of which major you go into, the semiconductor industry is a rich treasure trove of opportunities, right? So keep that in mind. What are some of the immediate next steps and programs that will be open to you as a follow-up? Many of you have, I'm sure, heard of this program that we call STARS. Some of you perhaps have even applied for it and have been accepted and and are looking forward to being part of this experience. But this is an academic summer internship. That's the way I like to describe it, right? Where it's an 8-week deep tech boot camp that we put you through this summer, where we do two things, right? You'll get to do a whole lot of fun hands-on stuff, really understanding what it takes to design and manufacture semiconductor chips. But the second thing that it will do is it will also give you a head start on a lot of the content that you will get to experience in your sophomore year, in your junior year, in terms of technical concepts, right? And getting that head start essentially means that when you encounter that material during the fall or the spring semester, you'll be that one little step ahead of your other classmates, and you'll say, I know exactly what this guy is talking about, right? When you encounter it the second time. And so hopefully those are the two benefits out of an experience like this. But the intended goal then is to make sure that through that deep tech boot camp, right, you will be highly sought after by the many companies that will come to campus during recruitment time and during the IR and shortly after for summer internships the year after, and the summer after. And so we will have a few different tracks for those of you who are participating in the STARS experience, a chip design track and a chip fabrication track, and new for this year, an advanced packaging track, right? Where it's not just about manufacturing that chip, but then putting it into the right package so that you can then use it in a product, right? Because you can't use bare silicon dies, right? You're going to have to protect that, and you're going to have to make the connections so that you can push data into the chip, suck data out, right, through those interfaces. So that's sort of advanced packaging in general, and the more sophisticated it becomes with larger chips, with trying to stack multiple chips one on top of each other. That's really the field of advanced packaging, and so you'll get to hear there'll be some subset of students in this STARS experience that will get to, they'll get to experience some of that as well. For those of you in the design track, our students last year also got an opportunity to actually design some fairly fancy chips, ranging from everything from little things like music synthesizers and stopwatches and all kinds of fun games to entire little processors, right? Including something like an 8080, which is an Intel microprocessor from the good old days, to something else which is quite popular called the Z80, to 6502 and a number of others. And all of the nice thing about it is all of these designs that the students did over the summer were actually sent out to a foundry, right, to get manufactured, and we now have silicon back, and so every student that participated in this is now holding a piece of silicon, a chip in their hand that they designed, right? And now imagine when you go out and talk to a company for a summer internship the next year, right? You have a fantastic conversation starter, right? Plonk that down and say, look, this is what I designed last summer. Now let's talk, right? So there's a very rich set of experiences. For those of you who are not part of it in the summer, right? Don't worry. We have some plans for those of you who want to go off and do a company internship in the summer, but somehow want to be part of this experience after you come back during the regular academic semesters. We're thinking hard about how to put together an academic semester version of the STARS experience for those of you that want to be part of this during the academic year, right? So stay tuned for that as you get into the fall and spring, and hopefully we'll be able to bring that to you soon. We had a fantastic graduation ceremony, and you can see that the students really had a lot of fun doing this, and they found that it really, really helped many of them in terms of going one step deeper than what this course allows you to do, right? This course is much more of a breadth course. It lets you, sort of opens your eyes to the vastness and the various pieces that form this puzzle of the semiconductor industry. The STARS experience is very much sort of a deep dive, right? Which will let you just get hands-on and not just hear about stuff, but actually get your hands dirty doing things. Another follow-up, right, to the STARS experience, both in the summer as well as the academic version, is then an experience that we call VIP, right? Again, it's likely that many of you have heard about VIP. It refers to vertically integrated projects, and this is an experience where you'll have teams of undergraduate students working with grad students, faculty, postdoctoral researchers in some cases, right, on specific projects that are fairly long-term, right, in the sense that the project is long-term, but your involvement on a VIP team can be as short as sort of 1 semester, 2 semesters, in some cases as long as 2-3 years as well for some students, right? So you can think of it sort of like what happens in industry, right? There is a project which is ongoing, right? Maybe there's a product that is being designed in industry, right? And it goes through various iterations, right? There's the 2023 version, there's the 2024 version, then there comes the 2025 version. And you as a part of a design team kind of play a role, come in, work on that particular project for a while, and then you move on to doing other things, but the project itself kind of goes on, right? So the teams are very topical, so it's a particular focused on a particular topic. They are highly interdisciplinary. They're vertically integrated, which is undergrads, grad students, and faculty. They're large scale as well as long term, right? So the projects continue over a long time. We have a couple of different VIP experiences that are relevant to semiconductors, and these accept students who are anywhere from their sophomore year all the way through their junior year, right? So, and this is, you can do VIP for credit. In some cases, it even qualifies to be a senior design experience in a number of departments and a number of schools. Some students simply do it for the fun of it, right? Just to be part of something exciting, something hands-on, right, where they get to contribute towards a long-term project and learn a lot and meet fellow students who are really passionate about it, right? So you can almost think of it as feels strange putting it this way, right? Like a student club, but fit very tightly into an academic experience, right? And that's certainly been the case for the design system-on-chip design team. It's called Socket, which has been running for a long time now. It's run by one of my wonderful colleagues in ECE, Dr. Mark Johnson, and his team, and they go through this exercise of really designing a fairly complex chip and actually taping it out, right? And this is much more complex than what the students do in some of the designs that you saw in STARS, almost at the scale of something that happens in industry, right? And there'll be very specific sub-teams, and it's very organized, and you will actually get to learn a lot being part of it. About a year ago, we also launched a semiconductors VIP effort in Berk, the Berk Nanotechnology Center, for those students that really want to get involved more in the manufacturing and the silicon semiconductor fabrication side of things. And so that is a VIP team which is growing rapidly in size as well as ambition of, for the projects. So if you want to, if bunny suits are your thing, if you want to bunny up and go into the clean room and get to experience that environment and really contribute there, that is a wonderful opportunity for you to be able to do that. Undergrad students usually don't have the opportunity to do that. And this is a terrific way for you to get involved in things like that. Let's skip a little bit. I have some details here in terms of some of the chips that the VIP team puts together. Right, this is something that they taped out most recently. It is an entire processor chip that has a whole bunch of not only a CPU core, in this particular case based on the RISC-V architecture, but also a whole bunch of peripherals, right? Integrated memory, other peripherals that let this chip talk to a variety of external things, whether they be sensors or whether they be actuators and motors and things like that. This was actually taped out back in October. I think we're still waiting for the silicon to come back, right? And this will be a regular occurrence, right? So the socket team, will plan to send out a new chip every semester, right? So if you're part of this VIP team, you will get to be part of the chip tape out team for that semester or few semesters that you're part of that team. Finally, while STARS, the VIP projects, and the various courses that you will take in your majors are all ways of building up expertise and getting involved in a rich variety of experiences. There's also a lot of formal credentials, right, like the certificate program that I just mentioned, that you really should take advantage of because it really comes for free. Right? You make sure that you get the knowledge, but make sure you also get that piece of paper that shows employers, in addition to your interactions with them, that you really have that formal credential. There's a number of credentials that are launching. The College of Engineering wide undergraduate certificate is well underway. Actually, that number, I wonder, that's of course a big, highly outdated number. I believe the number now is closer to 140 or 150. There you go, 150 students enrolled in the certificate, including, I'm sure, many of you in this room. But then, as you enter into your majors, I said, right, ECE, both for BSEEs as well as BS Computer Engineers Compies, there's undergraduate concentrations that are active. There's close to 100 students that are enrolled in each. Our undergraduate concentration in material science is now fully approved, open for enrollment. Mechanical engineering is also approved, open for enrollment, and chemical engineering, industrial engineering are following fast. So by the time fall rolls around, it's likely that some of those will be, again, available. So this is something, as you get into your majors and as you do your coursework, this is something to really make sure that you get added to your plan of study, because it's very likely that in a lot of these departments, you will end up doing many of these courses anyway, right? And then it will be like one course away, right? You just add one more course, and there you have it, right? You will meet the qualifications for the certificate or the concentration. So make sure you really take advantage of these formal transcriptable credentials that are being made available to you. And then for those of you who are then interested in continuing on to graduate school, many of the individual majors and departments also have things like 4+1 programs. I know that we have it in ECE for sure. It's actually our fastest growing master's program where you get to stay one extra year and pick up a master's degree. Right? Also a great option for those of you who came in with a bunch of AP credit, right? For some of you, right? Because then you could sort of use that as your stretch goal and say, you know what, in 4 years I'm going to try to pick up that master's as well, or 4.5 years, right? Well worth the investment of a few extra months or a year. The best part, with our dual degrees, which is the 4+1 programs, you get to double count some credit. Right? You get to double count 12 credits, certainly in the case of ECE, of 500 level, dual level courses that will count both for your PS degree and also for your MS degree. Right? So it's really, you're getting a great deal for those of you who are considering sticking around for that extra 1 year. Right? And there's a lot of experiences even at that graduate level, including a concentration certainly in ECE, right, that you can pick up even at the master's level. Right? And even the curriculum at that master's and PhD level, there's plenty of opportunities for you to tailor that around semiconductors. Of course, it will be a little more advanced by that point, right? It won't just be blanket semiconductors, but maybe a sub area of semiconductors that you've really decided that you like and want to pursue, right? So plenty, as you see, as you go along for the next year, 2 years, 3 years, 4 years, 5 years, right? And those of you who decide to go all the way to a PhD here at Purdue, right? The next several N years, right? Let's just call that N, whatever that N is. So parting message to all of you, make sure that you take advantage of these things. Okay? And then what happens after you graduate, right, is those many partnerships that Purdue has formed, right, with all of those companies and all of those regions of the world, not just within the United States, right, will really be available to you to take advantage of, right, in terms of attracting you there, but also opening up doors for you for a long, rich and rewarding career, hopefully long career as well, in semiconductors and microelectronics, no matter which part of the world you choose to live in, right? And so that Purdue Semiconductors stamp that you will get, that you were part of the Purdue Semiconductors family, right, will continue to hold, in high value as you decide to pursue your careers. So I'll stop there, right? And hopefully that gives you sort of this big landscape of the many things that we're doing here at Purdue in semiconductors, and some of the cascading opportunities that you have available. And we'll just throw it open for any questions that you may have. Anything is fair game, right? From what you heard to majors, all that. Go ahead.
Right. So to start off, the semiconductor industry itself seems very confined, should I say, not allowing entry for new companies, sort of. Are there any opportunities for startups, especially here at Purdue, to contribute to the semiconductor industry, and what part of the supply chain would that be?
Yeah, that's a great question. I think historically, there are certain parts of the semiconductor supply chain and semiconductor industry that have a high barrier to entry, right? So for example, if you say, oh, I want to start a fab. Yeah, good luck with that, right? Do you have your $10 billion? Sure, then you could think of it, right? But there's plenty of pieces of the supply chain and parts of the semiconductor ecosystem that are not that capital intensive, right? So for example, there's a ton of startups in the design space, right, that are saying, look, I'll design a computer chip, right, for a particular application, right, whether it be, it could be anything, right, from new kinds of processors to new, what we call accelerators, right, chips that would help you execute certain workloads or certain applications much faster at lower power, more secure way, right? That space is just bursting with startups that all have their own unique angle into it, right? So there's plenty of opportunities there because you don't have to have upfront capital of a few $1 billion in order to really get in business, right? I know of startups that have just had 3 employees, right, that have designed chips and have had, sort of multiple tens of millions of dollars worth of successful exits, right? And sort of some of my own undergraduate classmates have been part of that, right? And have retired at 29, right? So that dream is always there. But and so while there's certain pieces which are more capital intensive, which have a high barrier to entry, but there's many other pieces where I think the boundaries are much lower, the barriers are much lower. At Purdue, certainly at the master's level, for some of those 4+1 experiences that we talk about, certainly in ECE, for example, and I keep saying ECE simply that's because that's what I'm most familiar with. There is a +1 year experience called the project track, which puts you through exactly this kind of an experience called ideas to innovation, where you will start with a problem of societal scale importance, right? There's a problem that I think I can use technology, in particular chip and system technology, to solve, and then you will make not only a technical case for, look, how do I design this product, but also hopefully a market case for it, right? If I were to design this, right, what are the opportunities for me to turn that into an actual product, into a company, right? That can then that somebody will actually be willing to pay money to buy, right? And you will go through that experience for a year, including an entrepreneurship boot camp at the end, where you will learn about intellectual property, you'll learn about sort of market analysis, you'll learn about making a business case, you'll learn about, look, how do I pitch, how do I convince a venture capitalist to invest sort of few millions of dollars as seed funding into my company, right? So there's plenty of experiences at Purdue as you get deeper into that ecosystem that will let you go down that path.
Got it. Thank you.
Yeah?
I was looking at the list of companies up here.
Uh-huh.
Why are companies like Boeing listed?
Yeah, so great question. So Boeing first off does a ton in semiconductors and microelectronics. They have huge design teams that design chips, right? That design a lot of other electronics, right? So a lot of the end application that Boeing sort of produces, right, including all of the avionics stuff, right, has a ton of chips in them. Right? And Boeing designs some of their own chips. Boeing certainly puts a lot of chips together into systems. So yeah, and so there's a lot, and I would say Boeing is also an example of a company that straddles both the defense industry but also the commercial industry. Yeah. Right? So that's why you'll see some companies that you don't normally immediately associate as being, oh wait a second, I didn't know they did chips, but there's many such ones. What else? Everybody's excited, all clear? Awesome. Well, there's an entire team of both faculty as well as staff, including the wonderful folks in OPP, right? And hopefully all of your advisors as you get into your majors, as well as your first-year engineering advisors that will be able to answer any follow-up questions and certainly be able to direct you to some of us in the core semiconductors team that can answer any follow-up questions as well as point you, right, to more specific, as applicable in your individual scenario use cases, right, for you to get the most out of what we have prepared for you, right? So don't hesitate to reach out. Don't hesitate to talk to anybody on the team. If you have a question, if it can be anything from, look, can you help me get an internship at company X, to what course should I take, right? And so all of those questions are very welcome, right? So good luck. Hang in there, as I said at the beginning, 2 more weeks, and hopefully you'll have a enjoyable summer as well.